Let's talk about one of the biggest paradoxes in technology today. Artificial intelligence. It's completely exploding and it promises to help us solve some of our gnarliest problems, like climate change. But here's the catch. This whole revolution chews through a truly mind-boggling amount of energy. So what's the real story here? Is AI our secret weapon for a green future, or is its massive appetite for power actually a new threat to our climate goals? Let's dig in.
So yeah, this is the big question, right? It's really two sides of the same coin. On one side, you've got AI offering these incredibly powerful, super smart tools that can help us optimize pretty much everything about our energy systems. But on the other side, the actual data centers that make AI possible are becoming some of the fastest growing energy hogs on the entire planet. It is for sure a classic double-edged sword.
All right, here's how we're going to break this all down. First, we'll look at AI's just insatiable appetite for energy. Then we'll flip it and check out its potential as a great energy optimizer. After that, we're going to get into a really critical twist called the efficiency paradox. And finally, we'll look at what it takes to forge a genuinely sustainable future for all of this.
Okay, let's dive right into the challenge. You see, the explosion of AI has kicked off this incredible surge in the need for computing power. And more computing power, well, that directly translates into a much bigger hunger for electricity.
Okay, get ready for this number, because it's pretty wild. By 2030, the International Energy Agency figures that data centers around the world are going to need about 945 terawatt-hours of electricity. To put that into perspective for you, that's more than double what they use today, and it's about the same amount of electricity that the entire country of Japan uses in a year. Just wow.
And to make those huge numbers feel a bit more real, think about this. Just one large hyperscale data center can drink up as much power as 100,000 homes. I mean, we are not talking about a server closet in an office here. Nope. These are massive, industrial-scale facilities designed to crunch data and create intelligence on a scale we've never seen before.
And if you look at this chart, you can see just how big a piece of the story this is. Now sure, other big industries add more total demand, but look at the growth rate for data centers. It's just staggering. The projected new demand from data centers is actually more than all of the new demand from electric vehicles combined.
So you might be wondering, where is all this power actually going inside these places? Well, obviously the servers that do all the thinking take a lot of juice, but a huge chunk of the power, we're talking sometimes over 30%, is used for just one thing: cooling. These chips get incredibly hot, and keeping them from melting is a constant, massive energy drain.
And here's where it gets really interesting. This demand isn't spread out nice and evenly across the globe. Oh no, data centers love to cluster together, and that puts insane pressure on local power grids. Just look at Ireland. It's a huge tech hub, and data centers there already suck up over 20% of the entire country's electricity. That's a ton of competition for power.
All right, so we've talked about the problem, and it's a big one. But that is only half the story. So now let's flip the script, because AI is also shaping up to be one of the most powerful tools we have for cleaning up our entire energy system.
And this quote from KPMG, I think it just hits the nail on the head. The whole idea is that, yeah, AI has a big energy footprint, but its climate handprint, all the good it can do, could be way bigger. It's not just a power consumer. It's a genuine driver of energy innovation.
So how does it actually do this? Well, this is the cool part. AI's ability to sift through mountains of data in real time is an absolute game changer for our power grid. It can predict when and where we'll need energy, it can make renewables like solar and wind way more reliable, it can help stop blackouts before they happen, and it can make everything from our office buildings to our EV chargers smarter and more efficient. And look, this isn't just some science fiction theory, this stuff is happening right now. For example, Google used its DeepMind AI to predict wind patterns better, and that boosted the value they got from their wind power by 20%. They even used AI on their own data centers and cut their cooling energy by 40%. And globally, BCG thinks AI could help cut 5 to 10% of all greenhouse gas emissions. I mean, that is a massive deal.
Okay, so it feels like a simple trade-off, right? AI uses a lot of energy, but it can help us save even more. Problem solved. Well, not so fast. There's a plot twist here, a tricky economic idea that makes everything way more complicated.
It's called Jevons paradox, and it actually goes all the way back to the 1800s and coal. Back then, as steam engines got more efficient, you'd think England would have used less coal, right? Wrong. They used way more.
Why? Because the efficient engines made coal power cheaper and more useful, so people just found more and more ways to use it, driving demand through the roof.
So here's how that paradox plays out with AI today. Our gut tells us that if we make AI chips more efficient, our total energy use should go down. That's the expected outcome. But Jevons paradox warns us about this rebound effect. As AI gets cheaper, better, and more efficient, we just invent more ways to use it. And that new demand can totally wipe out the savings from the efficiency gains.
And this isn't just some dusty old theory. We are literally watching it happen right now. Every new generation of GPU gets more energy efficient, but that hasn't slowed down the absolute explosion in demand for them. Better tech is just fueling this incredible boom, which means we're deploying more hardware, not less.
So, if just making the tech more efficient isn't the silver bullet we'd hoped for, what's the answer? Where do we go from here? Well, that brings us to our final part, figuring out the strategies we need to navigate this paradox and build an AI-powered future that's actually sustainable.
Okay, probably the single biggest key to solving this whole puzzle is what we use to power this AI boom in the first place: clean energy. The IEA projects that about half of all the new electricity needed for data centers by 2030 will come from renewables like solar and wind. This is how you break the link, right? You let AI grow, but you do it without growing carbon emissions. It's absolutely critical.
Of course, technology alone isn't enough. You need smart rules of the road. And the European Union is actually laying out a pretty sensible three-step playbook here. First, just make data centers report their energy use. Second, create a rating system for how sustainable they are. And third, start setting some minimum standards. You know, it's that old saying, you can't manage what you don't measure.
And hey, it's not just governments. The industry itself is stepping up with some really cool innovations. Companies are making packs to run on 100% carbon-free power. We're seeing these genius solutions like capturing all that waste heat from a data center and using it to warm up nearby buildings. And I love this one. They're even using AI to make the AI data centers themselves more efficient.
And really, this is what it all boils down to. The absolute key here is to stop thinking about AI's growth and our energy strategy as two separate competing things. They're not. They're two sides of the same coin. You have to plan for AI's growth right alongside the expansion of clean energy and a modern grid. One simply can't succeed without the other.
Which leaves us with this final massive question. AI technology is moving at lightning speed. It's just breathtaking. The real challenge is, can we make our energy grids, our policies, and our big picture thinking move just as fast? Because the answer to that question is going to decide whether AI becomes a true partner in our energy transition or just an anchor that weighs the whole thing down. Thanks for digging into this with me.